All right, here we're going to learn about equations of circles. So every circle that's on a coordinate plane has an equation that measures the length of its radius and the x and y coordinate of the center of that circle. Before we really get into that, I just want to talk about what a circle really is. It's a closed figure with all points that are equidistant from the center. All that really means is that they're the same distance away from the center point. This is our center. Each of these points is the same distance away, and that distance is the length of the radius. The radius is just a straight line from any point on the circle to the center of the circle. If I extend the radius and continue to the other side of the circle, that forms the diameter. That's the straight line from any point on the circle to another point on the circle that's passing through the center. All right, so we need to know about radius, diameter, and we're also going to need to think about the midpoint and distance formula at times throughout this to find other attributes of our circle. So we have a couple examples here just talking about just parts of this circle, really. We're trying to find the coordinates of point P, where we're told point N is the center, point L is some point on that circle, and this dashed line here is the diameter. So that center has to be the midpoint of the diameter there. That center has to be halfway in between points L and P. So I could set up the midpoint formula. I'm just going to write those two for right now. x2 plus x1 divided by 2, y1 plus y2 divided by 2. I switched the order, but it really doesn't matter. We're just adding. So you're just finding the average of those. You could set up those equations and then find out, by solving that, you could find out those coordinates. I don't think that's the easiest way to do this. Given the picture, I'm just going to count. I know that I'm just repeating the pattern, going from there to there. That's going to be the exact same distance going to there. So this is going down 3 and over 2, down 3, over 2. So I'm really just going to repeat that pattern, down 3, over 2. So I went to the left 2, that means my new x-coordinate is 2. I went down 3, that means my new y-coordinate is 1. So the coordinates of point P are 2, 1. For the second part of this, we're looking for the length of Kn. Again, I could use the distance formula. And I could solve for that distance. But given the picture and what I know about Pythagorean theorem, I'm kind of just going to count this one again. I'm going to set up a triangle here. I'm imagining this dropping straight down and then coming across. Try that again, make that look a little bit straighter. Straight down, coming across. I know that that's going to the left 3, and it's going up 2. So if I think about my right triangle there, I'd be solving for C here. So that would be a squared plus b squared equals c squared, or really just the square root of that will tell me c by itself, or that distance. So I'm just going to simplify that. 9 plus 4 is 13. So the length of the radius there would be the square root of 13. You could plug in the coordinates here. I just think that's a little bit tougher than just counting. All right, here we're trying to find the center of the circle. So I would imagine drawing a diameter here. There's any number of diameters that you could draw. I'm going to draw this one straight across, and then I'm going to count to the midpoint. That's 1 space, 2 spaces, 3, 4, 5, 6, 7, 8, 9, 10. So the diameter is 10. That means the radius is going to be 5. So that would be that point right there, or 2, 4. All right. That's just basic attributes of circle. Now we're going to be talking about the equation of a circle. The equation of a circle and the distance formula are identical. So I'm going to show you the general form of an equation of a circle. Actually, I would like you to write this down. It's x minus h squared plus y minus k squared equals r squared, where the distance formula is x2 minus x1 squared plus y2 minus y1 squared equals the distance squared. They look really similar. The only real difference is this h and k change into an x and a y, which actually isn't really even a difference. The x value of your center goes here. The y value of your center goes there. It really is just an x and a y coordinate for the center of your circle, where this tells you the distance that each point is away from that center. That's exactly what the distance formula says. It's saying this point is some distance away from that, this point is some distance away from that, and together, that's going to tell you the distance that they are away from a certain point. That's exactly what this circle is. This is just going to tell you how far each of these points is away from that center of the circle, this x and y coordinate. All right, so really I'm just plugging these numbers in. The x coordinate goes here, the y coordinate goes there, and the radius of the circle will go here. So this is x minus 0 squared, that's the x coordinate at that spot, plus y minus 0 squared, that's the y coordinate at that spot, equals 3 squared. That's the radius squared. I'm going to simplify that a little bit. X minus 0 is just x, so that's just x squared. Y minus 0, same thing, that's just y. That's just y squared, and then 3 squared is 9. That is the equation of this circle. It only looks that simple because the center of the circle is 0, 0. What that's really telling us is that I can find any given point on this circle using that equation. This point with an x of 0, x of 0, and a y of 3. X is 0, y is 3. I don't know why that came out so funky. That's a point on the circle. You can plug in the x and the y coordinate in here, and if you get this number, that is one of the points on the circle. All the other points are going to be decimals here, so I'm not going to just plug in, but you can plug in any point, any x and y coordinate along that circle to confirm that it actually is in that circle. Similar kind of thing here. I'm just going to take the x value, plug it in for this h, take the y value, plug it in for the k. So x minus 2 squared plus y minus 3 squared equals 5 squared. And then I'm just going to simplify the 5 squared. None of this is really going to change. But 5 squared is 25. So that's really the final form of that equation. Alright, we're going to do a couple more. Even though at this point I feel like we might already have it. It's x minus h squared plus y minus k squared equals the radius squared. So x minus, it's a negative 1 here, so it's minus negative 1, that's going to change into a plus 1 squared, plus y minus the y value there is just a positive 1, that's minus 1 there, squared, equals 3 squared is 9. Last one, x minus negative 3 changes to a plus 3, so that's x plus 3 squared plus y plus 4 squared, and that equals 2 squared, which is 4. And again, any x and y value along this circle can be plugged in here and there, and if it's on that circle, you'll get an answer of 4. If you plug in a point over here, you will not get an answer of 4. All right. On those 4 problems at the bottom, you're either graphing or finding the equation of the circle.